Then in earlier stages of PT stages, PT penetration testing, there are different stages. There is a recon stage, there is an active information gathering stage, then we are in an exploiting stage of there, and a lot of other things are going to be present out there. This is the second stage, which is important. And this is not mandatory that it has to be done by an external security contractor like me, which I usually go and pen test applications and see what are the vulnerabilities on this as well, right? This can be done by a normal cybersecurity engineer or a security engineer in the organization. And nowadays it is expected of any security engineer to perform the scans of them. Right? There are many tools that are there that can be used by us to do the scans. One of the tools that is most commonly used Nessus, and one more is Kalkey. These are a very a very big enterprise level tools, and which is expensive as well, right? So this will give you much more detailed reports. I will show you a report for a second. Yeah, so this is for a different token. Right. This is a Nessus tool, a report for that. We had scanned a particular machine for vulnerabilities, and here we were able to identify different vulnerabilities in this situation, right? There are critical vulnerabilities, high vulnerabilities, medium, low, medium, and info. So this is a very vulnerable machine, so that is why we are seeing the number of vulnerabilities is very high. But if you see in a real-time scenario, it will be a lot cheaper. Sorry, not cheaper, lot less, right? So because main reason is the organizations would have patched their systems on a regular basis and things like that, right? So if you're someone who is regularly scanning and fixing the vulnerabilities, this is going to be very, very, very small, probably 1 or 2, maybe 10 maximum in some cases. If there's a new vulnerability that comes in, it keeps on showcasing out there, all right? So this is the tool that is used for doing this is the expensive tool. This is going to be there. There's one more tool that can be used by us for doing this activity. That tool is called Nmap, right? It is also called as a network mapper, right? Understanding this tool is very, very important. One main thing is that a lot of teams who are working in organization, especially in a DevSecOps environment, they are not purchasing the expensive tools like Nessus or Kalkey. They are expected to run scans using Nmap. That is mandatory requirement of them, right? And one more reason I'm covering Nmap here is that if you are going into cybersecurity, if you are going into a role where you're securing the network, your Nmap is definitely going to be part of the interview session for sure, right? The main reason is that it will give you basic understanding how the network scanning is supposed to be there. So what are the things that we need to know about that? Everything will be able to be identified when you understand how the Nmap works out there. So that is what we are going to look into that part, right? Before we could go further, there are two types of network scans that we are going to look into that part, right? So one is called as an internal scanning, and other is called external scan, right? Let's simulate a network. Okay, the cloud always represent internet, and there is a device, and this is the network, right? Organization network. In the organization network, before we could go further, there is a firewall. So a lot of you may not be knowing what is a firewall. Firewall is a first line of defense against any organization. It is going to look at things like IP address, port number, and things. to decide whether to allow a packet to come inside the network or not. Yeah. So inside the network, you're going to find other devices that are present out there. So this may be your system laptops. This could be your internal server and so on and so forth. And the thing is that this network will have something called as a private network, meaning the IP address here is not routable, right? There's something that needs to be there is a NAT for it to be able to connect to the other devices on the network. At the same time, let's assume this is a t-shirt manufacturing company and they have a website for sales, right? For selling their tools out there. So this particular web server where they are going to sell the t-shirts are not going to be in the internal network. That will be in a DMZ or a demilitarized zone. And these devices may be running on a public network, right? This may be running on the public network, and this could happen like this. Or in real time, what could also happen is that there may be a cloud provider, something like an AWS, and inside the AWS, you're having your web server. And both the situations, you're having a public IP, right? In both the situations, you're having a public IP. So meaning, what do you mean by public IP and private IP? Public IP is I can reach that device from anywhere in the world. Meaning I can open the website was hosted on these servers from anywhere in the world. Whereas in the private network, from outside, I cannot be able to work on this. I will not be able to open the connect to the devices out there. So that because the main reason is the IP address will not be supported for routing purposes. For instance, when you open your Wi-Fi, you might get IP address 192.168.1.x or 10.0.0.x. X may be the number that is changing. It will go from 0 to 255. Anything in between that one. All right. So that is the scenario is that. So, but again, yours IP address cannot be reached from outside. There's some kind of a process called NAT is happening by your Wi-Fi router, but you cannot reach directly from outside to your network without knowing how to reach it. Okay, that's how it works. So what you mean by this is the scenario typically you're going to work in an organization, okay, and this is where you're supposed to be doing all that. So right, you are both responsible for security of the devices here and the both security of devices in the cloud or in the public network. This is what you're supposed to be securing it. So I need to scan these networks for that component, right? So now when you talk about external scan, since these two devices are reachable from anywhere, this is called as an external scan. So I may be running my scanner on this. I may be running an Nmap in my laptop and trying to reach out to these devices and identify vulnerabilities in this scenario. Right? This is an external scan out there. So there here the initial setup is not going to be an issue. All I need is that I need the IP address and then I'll be able to run the scan of it. Nothing else is required. And this is basically because external net devices which are public facing where anyone can access it is more susceptible to attack because the security for that is limited and everyone will know about the IP address. It is not hidden or anything out there, right? If you don't know the IP address, you cannot attack that IP address. But unfortunately, from in public, facing websites, that is going to be very difficult. Right? Always, we are going to first do the scanning of the external network, right? External devices, external scanning is going to be conducted first. So what about the internal network? So meaning I told the internal network here, right? We spoke about this component of the network is not reachable from the outside. Meaning if I run an Nmap scan from here, it will not forget about coming to the firewall and getting blocked. It will not reach to this network only. The packets will be dropped at the internet level itself. Your ISP itself will drop it. So in this case, how is that? You can scan the internal network. There are multiple ways that you can do. One of the ways you can do is that the you will have to go to the destination network yourself physically, connect your laptop or your device to the network and run the scan. One is doing that part. Or you can do is to set up one of the devices, something like, you know, any desk, right? What is like desktop sharing attitude software. I can use it here and here, run the scan, control this device from here and scan the network from here out there. The thing is that the network scan, the packets, the generated that is happening, it's happening from here itself. So one is either physical, second thing is any desk or a remote desktop you can tell. This basically happens in a small organizations where the network budget is limited, so there is going to be there. But in a large organization, what is going to happen is that they are going to give you access to a VPN, virtual private network. Once you connect to the private network, there is going to be an internal VPN tunnel established from your device to the network, and you will be assigned an IP for the internal network, and you'll be able to send packets and run the scan. That is how it's going to be there. So a lot of times when you go for an interview and processes and things like that, or in an organization, when you discussing about it, they might ask what kind of a scanners you are running, what kind of a scans are you focusing on? Because I've seen people who work on internal scans are usually not working on external scan. Both is going to be very rare, right? So that is not, we see auditors working on it, both the cases, but internally, most of the time, security engineers work only on the internal scans, right? So that is how it's going to be there. So this is how the basically scans are going to work, how the internal part. But my question is, you should be asking is that why scan, right? So scan is why we scan, we want to find, the answer is find vulnerabilities, right? How do we find vulnerabilities in any situation? That's my question. So how do you find vulnerabilities? So now, in order to find vulnerabilities, see the PT is, you're actually hacking out here. You're actually hack out there, you're nothing out there. But here we are finding the vulnerability out there. Okay. For instance, let's say if there is a wanted person, you see the photograph and you identify someone exactly like, then you will report to the authorities that the person in the wanted list is in this particular location. That is what a vulnerability scan is going to be there. So what are the things that we are looking at? We are looking at ports open, what ports are open out there, right? What services it may be running, what services it may be running. Also, it may be the version number also. So this is basically what you might tell. It is giving out information, right? Or an attribute also. How is this attribute going to help you the information to get? Which is not a vulnerability. Let's say telling someone who looks someone like that, how can it can be a vulnerability? So this needs to be mapped, right? This need to be mapped to something, right? So for instance, one more thing we need is the voice type also. So what happens in reality, real time is that there's something called as a CVE detail. So whenever if there's any kind of a vulnerabilities in any kind of a product, right? So what is going to happen is that a vulnerability number is going to be assigned to that and a fix is going to be assigned for that as well. So that is the reason you might see your Windows is updating security patches or any product you're using. It is going to give those security patches. That is important out here. So that is what it is working on. Okay. So now, how does this information going to help the attackers, right? So here you could see that there may be multiple tools available out there, and CV details contains all the information about all the vulnerabilities that are present out there, right? So in see here, 490 created 9 CV update in last 30 days and so many information. This is going beyond one time, right? You can see here 2,04,901 vulnerabilities that are present on an average number of vulnerabilities that were identified, and is giving a severity ratings as well. So here, for instance, let's say when we go to product, let me see PHP, just to give an idea. PHP is a programming language, and you can see the total number of vulnerabilities identified in this particular is 728. Right, this is 728, and you can see the latest one, that is version is 2024 11236 is the latest version of that. It was identified in somewhere November 2024. So here it is telling that there is a critical vulnerability, and it is telling which version that is before that. Anything which is version before 8.3.14, this vulnerability is going to be present out there. That is the scenario. As an hacker, what I want is that this particular information. If you are running any older version of one PHP and things like that. Okay. In a similar way, you can get same kind of an approach for a lot of other components as well, right? Apache. Let me check. Here, this is your typical vulnerability for your HTTP server, Apache Web HTTP server up there. So let me see this. So this is going to give you CV details, is going to give you information about what vulnerabilities are there. But Exploit DB is one of those databases where you might get information about how do you hack that particular component out there. For instance, let's say for this, there is no publicly available attack. So I can still find it depending on that. So you could see that Apache Tomcat denial of service and Apache 2.4 buffer overflow. There is a clear steps how to perform the attack out there and cause a denial of service in this particular version of this particular thing, right? This is the one. The CV details what I'm searching. This is conducted in 2021, 44,790 is the vulnerability number in the year out there. So as an hacker, if I want to do this kind of an attack out there, because not everyone is going to be an expert in hacking, they are going to do a lot of is copy and paste, right? So that is what we see common out there. But if they want to run this particular attack vector, right? If they want to run this particular attack vector, they need to know what is the version of Apache they are running out there. What is the version of Apache running out there? So let's say we'll put the CV number here itself, right? So here it is telling the issue affects Apache server 2.4.51 and earlier, right? So any version greater than 2.4.52, this vulnerability is not there. But I should be able to scan and get to know, right? So this is how we have to find. So now, as we saw, it is important for us to collect as much information as possible, right? If you're an internal member, right? If you might be, because I'm talking more from an external perspective, Let's say if you're an internal member, you will be able to look at, okay, when I'm scanning my server out here, it is showing me ports that are open. Is there any unwanted ports that are open out there that I can check? Is the version information disclosed or not? I can check. If version is disclosed, I can tell the team, operation team, to remove the version information, right? If this version is vulnerable, right, I can tell the team to update the version for that particular part and fix that vulnerability before someone else finds this vulnerability in real time. And this could going to happen very common, right? One of the main reasons why we do it once in 15 days or once in 30 days for sure is that the tools, like your code is going to be much more, you'll have a little bit of time to work on your code and fix that vulnerabilities because no one has a public code. Your code is not public to everyone, right? Whereas in something like an Apache gives out a vulnerability, and the 2 or 3 days you will see in the exploit DB payload is there to exploit your vulnerability. For the next 30 days, or if you're doing once in 3 days, 3 months, for 90 days, your Apache server is going to remain vulnerable because it is not been fixed out there, right? And the vulnerability rate where you find for third-party tools or ones that is most commonly used is going to be very, very active. It's going to be right because every time you see once in 2 months or 3 months, Apache keeps on getting vulnerabilities and it keeps on updating out there. Right? You have to keep up with that part. So we need to know that at an earlier stage how fast it is going to affect and try to fix it as early as possible. So that is the reason we need to scan those things at an earlier stage, right? So there are situations if you have done properly, if you have been regularly conducting, you will know how to hide the version info, right? Hide the version info. Then it is going to reduce the significant information things under. So we can look into those things. Right. So any questions till now, till the reasoning behind scanners and components out here?
No, sir.
Okay, fine. Let's continue. So before, yeah, wisdom.
Yeah. Can't in case of scanning and checking for vulnerability, is there no tool that can automate that as the present world that we are now living in? That okay, you said if it is 15 days, 30 days, or 90 days, after 30 days, is there no tool that can automatically scan the entire system to show if there is any vulnerability about
Yes, yes, that can be done.
okay.
Your tools like Nessus and Quali is going to work on that, where you can schedule a scan and leave it, and every 15 days or 20 days it is going to scan it out there, right? But at the same time, it can automation process is totally possible out there. But I would really not suggest doing automating the scan. The main reason is the scans can be very network traffic intensive. Amount of packets that is going to be sent is going to be very high because now only we will see one of the scans. We will see it will send out 65,000 packets in a very short span of time. The next section we are going to talk about it. When you're dealing a Nessus scanner, this is going to be very bare minimum 65,000. It may be sending up to 100,000 or 300 or 400,000 packets for a single device, not for the entire network, for a single device. That is how. So we have to be aware that there is no large activity is conducted out there, and scans are usually conducted on usually on a weekend, evening times or anything like that, mainly because the traffic is not going to affect your regular traffic, right? So they don't want that to happen. We have seen in many cases where I have scanned a network or a device server, the servers will be so sensitive, it will crash, right? And it has been a nightmare for organization because we initially tell them it is not a good idea to scan on a working hours. Right? They tell we can manage, it's not going to be an issue or anything. Then we run the scan, it crashes and they have to scramble to get it back because the business is depending on the website. So they, unless until you know for sure nothing is going to be done, you can keep the scanner at that time, and it will, once it will scan, it will generate the report and keep it for you. All right. So we'll see if possible, if there's a time, I will show how a Nessus, process will look like. So for you to be able to scan in that particular way. Hope it cleared your question, Wisdom. It is possible, and especially when you're doing DevSecOps, right? DevSecOps, here you're actually in the CI/CD pipeline itself. We're running the, from a web application scanner perspective, I'm telling you, you're running both DAST and SAST and SCA composition analysis, looking at third-party tool, you're looking at image scans and everything. Every time a new code is implemented, right? Every time there's a commit to the code, all these scans will be done at the application level out. Okay.
Very clear. Thank you.
So now we need to know the ports out there. So you may be wondering, so what is Karthik talking about ports, right? So now before going into scanning, we need to know a little bit things. So an IP address is the unique, every device that is going to be there will be given an IP address to. This is going to tell how to reach to that IP address and able to communicate with that part. That is going to talk about that. At the same time, port number, right? Let's say you're running a server, you're running an FTP service out there, SSH out there, HTTP, right? And HTTP. When a new packet comes in, right, the destination address is, let's say this is IITS 10.10.10.10, right? There are 3 packets out here, one for FTP, one for SSH, and one more packet for HTTP, right? In all 3 packets, the destination IP address is 10.10.10.10. All of them are bound to this particular server itself, right? But once the packet reaches here, how does the server know which service or which program that packet should be added to, right? How do I know which program for that? In order to make this process easier, they are giving the port number. Okay. So what is going to happen is that every service or every application, right, is going to be attached to a port. So meaning, for instance, SSH is going to be attached to port number 22. Whenever I receive a packet for SSH, it will come by default on port number 22, and then again it is going to be handed to the SSH program, and that is going to manage all that. So anything going out is also going to be on that particular response, is going to be on that particular port itself. So that is how it is going to be. So for each and every service, a port number is going to be assigned. For instance, for FTP 20 and 21, SSH 22, HTTP 443, and HTTP port number 80, right? So based on this, we can tell about that. So now, when I'm scanning a particular component, looking at the port number, I can tell what services may be running in that component, in that server. That is one way of knowing about it. Okay, this is, we need to know how a port works for us to understand the scanning part. We also need to know how a very important concept called TCP handshake. So TCP is a transmission control protocol. This is a protocol that will make sure the 2 applications are able to communicate, right? 2 applications are able to communicate, and all the data that is being sent is received in a safe way, right? That is what the process is going to be. And usually what we see is that there are 2 components. One is TCP and one is UDP. UDP stands for user datagram protocol, right? So this is not, UDP does not care about, the accuracy of the data is not reliable. It forgets, it sends and forgets of that. But how does a TCP knows, make sure the data is received is correct or what, right? How does it make sure of that? Here, what is going to happen is that there is an acknowledgement sent for every message received. Just like, let's say, whenever you're receiving a message, let's say you get an Amazon packet, for delivered, a message is also sent back to the acknowledgement sent back to the Amazon telling that a packet was delivered and the customer collected the packet out there. There is an acknowledgement going back out. But in a similar way, let's say you're going out on a vacation, you will get postcard, you post it out there. There is no acknowledgement sent. It is just fire and forget. We are just assuming that the postcard will reach the destination in time, right? In the way we expect, but there is no guarantee for that. Right? There are two different types of that. So postcard is like your UDP. There is no communication that's happening. Where TCP is something going to be handshake is going to be present out there. And this is going to happen for every communication that is going to be present out there. For instance, here we are going to be, let's say, two devices wants to communicate, A and B. Before sending any data, A is going to send a message called sync packet, right? This sync packet is just one way of telling, hi, I want to communicate. Okay. So for this response, B also wants to communicate back. What he is going to do is that he is also going to send a hi. That is much sync packet of them. But remember, TCP protocol uses acknowledgement. So the first packet was sent sync packet. So now the B has to send that I received your sync packet. There is an acknowledgement has to be sent out there for that. So there is a sync being sent. And finally, A also has to send an acknowledgement for the sync packet received from A. This is going to be the processor. So usually this is called a three-way handshake. This is called a three-way handshake. This is going to be there for any communication that is going to be using a TCP protocol, right? This is going to be there for any communication using TCP protocol, whereas in UDP protocol, you're not going to find this three-way handshake. That is the reason why 3CP is set to be slow and UDP is fast. Main reason is UDP does not wait for the acknowledgement send to receive to send the second packet. If there are 10 packets to send, it will send all 10 packets and forget. Whereas TCP will send one packet, it will wait for the acknowledgement, then it will send the second packet, it will wait for the acknowledgement, and no packet is going to be sent without an acknowledgement, right? If I don't get the acknowledgement, it will keep on sending the older packets, never send the new packets out there. And we are going to use this flow out there to understand how the scanning process works out. Okay. For instance, let's look one small example. I will show you a Wireshark example of the TCP three-way handshake. Okay. So what I've done is that I've set up a TCP connection for a website called testfire.net, and that website is sharing me all the resources here, what I've seen in the page. The image, the contents and color and everything is going to be sent out by the HTTP protocol, right? Before this could happen, there was a three-way handshake that occurred out. Right? If you go here, you'll be able to look into that part, right? So before any communication in a web application takes place, there's a DNS request sending. This is the domain name testfire.net, and I want to know what is the IP address for that. See here, query is going to be there. This is the DNS request sent to the DNS server telling I want to know what is the IP address for that. And finally, I'll get an answer for that as well, right? So here you could see the next packet that is going to be there. It is giving me the IP address for testfire is 65.61.137.117. After this, right, This is an UDP protocol. You could see here, user datagram protocol. There is no acknowledgement for that. I've sent a request. I got a reply for that. That is what is going to be there. Once I get the IP address, this is where my TCP communication starts. And here you could see there is a three-way handshake that is happening out there. Sync packet, SYNAC packet, and ACK packet is being exchanged. And only after that, your HTTP protocol communication starts, and the data, whatever the data is being exchanged, that is going to take place out here. First, always is going to be SYNAC packet and ACK packet out there. Since they have sent out two sync packets, right? So you're finding different number of SYNAC packets out there. Okay. So this is the process that goes into play for us. Okay. So now, for the sake of practicing this, and it is not recommended to practice your network scanning and other activities on any website. It is a network scanning is, if you're doing it without permission, it is a criminal activity. So we want to be able to still practice it. What I'm doing is that I'm using this VMware workstation tool for running my small network out here. Okay. So one VM virtual machine is a Kali Linux. It is a full-fledged operating system which is running inside my Windows machine. I'm able to run it using the VMware Workstation Pro 70, right? And I'm also going to run a completely standalone virtual box, Linux machine. This is going to be the victim's machine out there. So this particular server is running a web server out there, and we can try to hack this activity. So in our main course, we use this particular machine to practice our ethical hacking on a web application part, right? So we are going to look into that section out there. We'll see how we can access this, try to do network scanning on this device and get some information on that part. Okay. The very basic way, what we are going to do is that we are going to start working on the Nmap scanner out there, right? Nmap scanner. Nmap scanner is by default available in Kali Linux. Kali Linux is a Linux distribution, which is used for offensive security. Offensive security meaning hacking itself. Defensive basically protect any network. That is what. So it contains more than 700 plus tools for pen testing activities. We don't use all of them. If you are hardly using 10 to 15 of them based on the situation, right? For every kind of a stage of pen testing, there's a different tools that are available out there. You can use out there. So Nmap is going to be by default available out there, right? Let's say you don't have an Kali Linux and you're someone who are working on Ubuntu, right? So if you're running an Ubuntu, Nmap is not available by default. Okay, by default it is not available out there. So what you have to do, running an apt install, it is very simple, and give Nmap, right? Nmap. If you're not running as root, make sure you add the sudo command. You need sudo permission to install out there, right? If you're running in Rocky Linux or Red Hat, you can use dnf install Nmap. Okay. This will probably, it's a very lightweight program. It does not take too much space or anything. It will be able to do a lot of activities for, right? So this is how it is going to go. So now let's say how does this scan is going to happen out. So remember, we spoke about port number. Let's assume the server is running on port number 80. Okay. Port number 80 is HTTP. Okay. So when I'm running a scan, let's say if I want to scan on port number 80, I'm going to send a SYNAC packet for the port number 80 out there. Okay. Since the port number 80 is open here, this is going to send back a SYNAC mechanism out there. Let's say the port number 80 is closed, right? It is not going, because every system is going to have 65,535 ports, and only few of them is going to be open out there, right? Nothing else, rest of the ports are not going to be open out there. This is the minimum of them. So if I reach out to a port which is in a closed state, I will not get a SYNAC packet. I will get something called as a reset packet. Telling that it is telling that this packet, this port number is not open. It is a reset out. So the must for my thing, if I want to identify a particular port is open or not, I will the scanner or the Nmap is going to send a sync packet to that, and it is going to analyze the response, right? If the response is SYNAC, then it will tell the port number is open. If the response is reset, it is going to tell the port number is closed out. Understand one thing, the lot of port numbers are predefined. Services port number 99.9% will be used for HTTP only, right? Unless until the network engineer or the operations Linux engineer who's working on it is changing it to do some other activity, right? It is not going to be used for anything else. Port number 443 for the HTTPS, for a secure HTTP, it is going to be used for that as well. Okay. So now let's look at the basic command that is going to happen. So we have understood what is happening out there. So let's say by default, Nmap is very simple. Give the Nmap command followed by IP address. Okay. Followed by, or I can give Nmap followed by domain name. Without IP address, your network scanner is not going to work. Okay. Without IP address, with your network scanner is not going to work out. So this is called as a default scan. So what are the things that it is going to do? Okay. So whenever there is a domain name, see domain name is like apple.com. So this is a domain name. For instance, humans can remember names, but computers, they don't deal with names. They always deal with numbers. So when two devices wants to communicate, they will always use IP address only, right? They will always use IP address and it will never use domain name. But whenever for us, it is going to be difficult, right? Think about, you can hardly remember 4 to 5 phone numbers, right? Mostly that phone numbers, it belongs to family members and rest of them we don't need. So what you're going to do, you're going to have something like a contacts in your mobile, which is going to store all the numbers for all your friends and people you know. But can you remember minimum 100 people names, right? That's not going to be difficult. More than that also we can remember anyone, you can remember them and then you can search for that contacts. So that is what a domain DNS server usually does. Okay. So whenever there is a domain name given in anywhere, it may be a ping, it may be Nmap, it may be any other place you're doing domain name. This domain name is going to be sent to the DNS and DNS will do response with an IP address. DNS is a centralized large contacts program that is available out there, which will hold on to all the IP addresses for a particular domain names all over the world. That's going to be there. Okay. So what is going to happen? DNS also does something called as a reverse lookup. So meaning from domain name, it will tell the IP address. And let's say you have an IP address, it will also tell the what is the domain name associated with that IP address also. Sometimes there will be more than one domain name assigned to a single IP address. That's also possible. So on a default scan, what happens is that your default scan, your Nmap is going to do multiple things. It is going to first ping the IP. Okay. Then it is going to run a DNS lookup. It could be both reverse and then it is going to do a TCP scan. So meaning, what are the three things it is going to do here? In a single example I can give is ping is one of those. Let me close this. Let me increase the font size. So if I want to know whether a particular IP is alive or not, if the system is on or off, I am going to use a ping IP address, right? I can give ping. The IP address for the B box or the machine I'm using is 190.168.178.146, right? So for instance, if I give into dot 168.178.146, if the device is alive, I'm going to get a response like this, right? Let's say, let me put that device to sleep, meaning I'm going to shut it down temporarily for a couple of seconds. Right?
मैं तो वो हो गए चाची और की
क्यों?
वो
Can
पूछ के आए
you
थे
guys,
पढ़ता पढ़ता का वो बतागा
guys, can you put your mic on mute?
शायद उल्टी
Right.
मौसी का होता वो
Right. Now you can see that my target machine is in a pause state. Please put your mic on mute, guys. So now if I run the same command, I will not get any response. Right? If I put the same command, I will not get any response. The main reason is the target machine is down. It is in a, here it is in a suspended state, but in real time, this is not going to be it is going to be turned on, or it is not reachable. That could also be the one of the reasons. Once this is active, see, as soon as I turned it on, I started getting the response for this. So first thing foremost, it will do is a network scanner will run a ping scan. Okay. So second part, it is going to do a NS lookup order, right? Something like this, it is going to be there. NS lookup, there is a main build command. I can give the IP address. Here it is not going to come out with anything. Like for instance, I can do NS lookup google.com. This will give me the IP address that belongs to google.com. 142.250.77.174. So in the background is going to do that activity. Right? If you give same thing, right? It is not having a what is the domain name, it is not able to give, but it is some situations if there is only single domain assigned to a particular IP address, it will be able to give that information for you. Okay, here there may be more than one domain name assigned to this particular IP, so it is not giving answer for that part. Okay, and this is going to be done, and finally it is going to send a sync packet for that part. Okay, so it's very simple. I can give nmap and give the IP address 192.168.178.146 and press enter. Right? In a very short span of time, what it is going to do is, you could see here, right? It is almost instantaneous, right? This is because I'm running in my own subnetwork. The network traffic is very fast. Okay. In this short span of time, it is sending 1,000 port scans. So one more default thing is that it is going to scan top 1,000 ports Nmap. Okay. And you could see in this fraction of a second, what we saw is send out 1,000 packets to the destination machine, that is our B box. And in that it is telling 983 ports are closed, meaning I got back reset message from 983 ports. For the remaining of them, I got a SYNAC packet. And what are those ports? These are the different ports that are available out there, right? So these are the different services. There is no guarantee that this is the exactly the service out there. If I'm using port number 21 for FTP here, it may be showing out there. In reality, this could be running something else also. There's a very good possibility out there, right? If you have seen attended any one of our previous SSH, we changed it to port number, default port number from 22 for an SSH to 2222. All right. At that time, there is some other thing out there. It will not show SSH. When we do a deeper analysis, only then it is going to show up. Okay. So now this is a very basic scan. Okay. This is a very basic scan. It is not a ideal scan as well, right? This is something used to check, okay, just let me do a quick scan and see what is happening out there. Then we'll go from there. It is going to be there. But in reality, you should not be able to. You should be able to scan all ports. So scan all ports. So meaning all 65,000 ports. This can be done in multiple ways. One way to do is Nmap. If I can give port number P and -P right, and give the IP address. This is going to scan all ports. Sorry. Right. And let's say inside a time, I want to scan one particular port. So let's say I want to see, because if the devices are there, let's say there are 10 IP addresses. I don't know which of them is a web server. So I know that web server is running on port number 80. So I can run one particular port number only. When I get a response back as open, then I will know that is a web server out there. So how do you do that? Nmap -p instead of dash, you give a space and give the port number followed by IP address. Okay. So now I'll be able to tell which of them is a web server, which of them is not a web server router. That it can also be done. So also you can do is that you can read the port number. Multiple options are there. One is give the port number, or I can give port numbers. Let's say I can give multiple port numbers, varying of them are there, or I can give a range also. I can tell go from 100 to 500, scan all those ports for the first 500 ports. Top port is different than this. Okay, there's a list of most commonly used port numbers, and that what is the top 1,000 services that are there, that is going to be scanned here. But here it is going in a sequential order. Okay, that is how it is going to be done here. For IP address also, it is not mandatory that I can scan. I can multiple IP address at the same time. Right. For instance, let's do one thing. Let's scan the current network. Right. How do we know the IP address for the current machine? You have config. So I'm in the 192.168.178 network. So what I'm going to do is I'm going to do Nmap -p. I'm going to scan first 100 ports for all the devices in my network. So if you have someone who understands IP address and subnetting, you'll be able to know what is happening out here. So I'm actually scanning 256 IP addresses here. When I'm giving -24, I'm scanning all the way from 192.168.178.0 all the way up to 192.168.178.255. The first and last IP address is not used. It is used for network and broadcast IP, but it is here. Technically, it will scan from 192.168.178.1 all the way up to 192.168.1.254. All the devices, even if device is present or not, it is not going to care about it. It's going to scan all those devices. Right. See here, now it is going to take time. Little bit time. Right. So it is able to tell how many devices are there. 1, 2, 3, 4 devices are there. One is my Windows, one is my Kali Linux, one is bbox, and some other machine is there. It is scanning that itself. So what is happening here is that first and foremost, it will start sending a ping request to all the devices 192.168.178.1 and keep on going out there. So whichever the devices will reply back telling that I am alive, then it is going to start sending the sync packets for that device only. It is not going to randomly going to send the devices in a particular way. It is going to wait and see the ping response, and that is going to happen out there. Okay. But in real time, this is not a ideal way to go. This is not an ideal way to go out there. Just a second. Right. So what is going to happen is that it is by requirement servers config to drop ping request. Okay, it is going to drop a ping request by default. That is going to happen out there. So meaning whenever you're scanning something, if I send a ping request to that, this is going to drop. There is no reply is not going to be sent out there. In a traditional approach, if you go with a normal Nmap scan, what is going to happen? It will send a ping request. If there is no response back, it will not scan further. It will not scan further. This should not happen. Okay. In real time, we should always use an option called PN that is going to disable the ping scan. And I have to give something like ST and -P -. So meaning it will scan all 65K ports for all devices, even if ping fails. And this is very important. And this is why your network scans are going to take a lot of time. And here what is going to happen is that it is going to send, let's say, I'm giving this IP address to 192.168.178.0. I told there are 254 devices out here, right? There are 254 devices. It is going to do 254 into 65K packets of data is sent and received back for me to get to understand what is happening in real time. And this is important. This you have to make sure of that. Okay. Because top 1000 ports is not going to be of any use. The main reason we do this part is that to check is there any backdoor programs running on your servers, right? Let's say someone hacks your server. You are not aware of that because we always have to assume that we are compromised, right? So that is how a zero trust is going to work. We are going to assume something is wrong. Always someone has gaining access. How do we prevent the attack, right? How do we reduce the impact of an hack is what is important. So what usually we'll do is that an hacker will hack into your server and he'll create a backdoor. So meaning he'll be able to come and go to a system whenever he wants. So for this, what is need to happen? He need to open a port. And what he's going to do is that he's going to choose a very non-common port. Something, let's say it could be out of 65,535, let's say I'll use something like 49453, right? This particular port is there. This port is not going to be used by any of the services in the world, but this port gets assigned to a particular service, and this is your backdoor service. Right? This is the malware, or you can call it a Trojan horse, you can tell out there. This is going to be, he is going to keep on coming into this part. But if you are doing a normal Nmap scan for top 1000 ports, right? This is not going to be scanned out there. We will not know this port is open or not. Right? It is very, very important. We have identified a lot of times vulnerabilities like this, In couple of cases that there was a backdoor install, they had been hacked for some time and there was a backdoor open. We scanned it and we got to know, we checked because we saw a very strange port number that is open out, right? Your Nessus scanner will automatically tell this is a Trojan in IP address. So when we reached out to them, they were not aware of it. Then they did analysis and they saw that there is actually a program that is running out there. In one more situation, what happened was they were running a GCP server, right? And it also gave a random port number. What had happened was GCP was tracking this VM, the instance that is there, via that particular port number. So what they did was they reached out to GCP telling that this particular port number is there. We don't know what it is. Can you check? So then they came back with a response telling that this particular port number is used by GCP for monitoring your instance for any issues, because they also have to provide security for your instance, right? Your GCP is providing responsible for some kind of a security. So for them to monitor your activities, they were running a program inside your instance and that was using a particular port number, right? But having a written confirmation from them is very important that this is what is happening out there. And there is no that, some hacker has not gone into your machine and able to, put up a backdoor in that. So always make sure you scan all ports, right? So meaning Nmap -pn -st, st stands for TCP scan. Okay, by default this is going to be there, but is always a good idea to specify. I'm telling port number, I can either use p or I can give -p 0 to 65,535. I can give there, followed by IP address, right? Usually here we are going to give the IP address range. Okay, there will be more than one IP addresses. On an average, let's say what is going to is that large organizations, we are doing about 100 devices. Okay, 100 devices, all those things can be going to be quite extensive. It's going to take some time. Nmap is not something good for doing large scans. Okay, because main thing you saw here, the output for the network scan, it gave like this. And think about for all your 100 devices, it keeps on going to give out in this particular way. It is going to be quite cumbersome to manage the output and things. Nmap is actually done as a secondary port out, right? After doing Nessus, we want to be sure, because the problem with these scanners are they can be a lot of false positive, lot of errors. So we have to be sure sometimes when we get that. If we get doubt, we always go to Nmap and check what is there. It is exactly what is supposed to happening or not. Then finalize on it, right? That's what is going to be there. But internally, when you're working in a small organization or medium-sized organization, number of IP addresses or devices in an is going to be limited, right? So probably you're running about 10 to 20 devices out there. We're not scanning the desktops out here predominantly most of the time. We are scanning the servers. We are scanning other devices that are there, like your firewall. It may be a load balancer. You may be having 3 to 4 servers for testing environment. Then there's one production environment server. And you might have 10 to 15 devices out there. Run those scans independently. It will give you a much more easy way to document it. It is not that you cannot run it all together. You can run. It makes things a bit more easier to document the process of it, right? And if you want to automate the scan, you can do a cron job also here. Okay. If you cron job is automatically to do some activity in Linux, you can run Nmap scans out there. But yeah, I would not recommend. Scans has to be you have to get approval, don't run scans. If something goes wrong without, even in the organization, at that time, you will not be responsible for the outage. So you can tell that I got permission to run the scan, so I run the scan, right? Then whoever granted the permission will have to answer for that. So it's better that way than you getting process out. Right. So let's look at quite a few other concepts out here. Right. So one more option we see when we're talking about TCP scan, there are two types. One is ST and one is SS, the scan option out there. So this is TCP, this is stealth scan. So what is the difference between this, right? So what happens is that, let's say, when you connect to a server, there's a three-way handshake, right? SYN ACK, and finally ACK is there. As soon as an ACK is received, a log is generated in the device telling that the IP. So let's say this here, the one device IP is there like 10.10.10.10 IP, 10.10.10.10 established connection. This is going to be there. But as a hacker, you're supposed to reduce your footprint, reduce, because someone, they got to know you got hacked on a particular day. They'll try to go through the logs and see, okay, there is a suspicious device out there which ran certain things out there. So let's look into that part. So we don't want to give out that information, right? Your information collection phase is always the longest one. Anything you take, any major attacks that has happened for banks or any large organization where there is happened, it is not something like what you see in the movies. It does not happen over half an hour or 10 minutes or 5 minutes. They get and then go into that part, right? It takes a long time to do that activity, maybe almost 4 to 5 months of prep time and doing the other activity for every attack that is going to be there, right? So the initial scans are going to be very, very careful. It is going to be spread out. They are not going to work on, right? At the same time, you don't get access to the target server directly, right? I think there was one supermarket chain got hacked a long time back, and they had a national, major problem, major attack out there. But that attack did not start on the server directly. It got hacked. The hackers hacked into the till machine or the cashier machine in the supermarket sitting in the parking lot of that. So because they connected that cash machine to the Wi-Fi and they hacked the Wi-Fi, then they got into that, then they got into another server with that. Then they kept on propagating and finally reached the main server that one. So that is usually how it goes. You never directly, it does not happen because there's enough security measure out there to prevent that from happening. So there's a lot of waste. Right. So I don't want to give out this information because there could be log and process happening. So what it's going to do is that they're going to look at a stealth scan. So stealth scan is very simple. It will want to send a sync packet. And as soon as I get a SYNAC packet, I know the host is up and port is up as well. Right? Host is also up, port is also up. I don't need to send back ACK packet out there. This is not required at all. This is not required at all. ACK packet is not required. So what it will do is that it will send a reset packet telling that I don't want to, even though I wanted to communicate, I don't want to communicate here. It will send a reset pack. The communication is cancelled and this log, the log is not generated. Why? The communication did not complete. The three-way handshake is not complete. That is how it is going to happen. Okay. So any questions here? So there's also one more protocol here called UDP, and this is a bit tricky, right? So in TCP, there's a three-way handshake. So based on the response, I can tell port is open, right? Whereas in UDP, there is no response. Let's say when I send a packet to that, there's no reply back, right? There's no reply back in UDP. So how do you think I can know if there's a UDP port is open or closed? And UDP scans are not accurate. Okay, UDP scans are never accurate, and that is something we have to accept and continue. But how do you think? How do you think UDP? I can identify if the UDP port is open or closed. So here, let's say this is my server, and there's a UDP port number 120 is open. So when I do an Nmap scan, I have to use -su for UDP. You remember for TCP we did ST. Here we ring SU for UDP, and del port number is 120. Okay. When I send a request out here to port number 120, it reaches here and it will accept it. And there is no response at all. This is a very, this is a very actual happening out there. So now let's assume I'll do the same request. Here the port number is 121 and 121 port is closed. So what's going to happen? Whenever the port is closed, what is going to happen? It's going to send back a reset message, a reset flag message or reset message is going to be sent out. So meaning no response means port is open. Response means port is closed. So now what I'm going to do? I'm going to send all 65,000 requests. I'll get back a response for all 65,000 ports except for 120. So based on this, I'm telling 120 is open. Okay. This is entirely different. For lack of response, I'm telling you port number is open. And if there's a response, I'm telling port number is closed. Right. But Nmap scans, UDP scan is never accurate. Why? Why is Nmap UDP scan never accurate? The reason being is that, let's say there is a firewall and behind that there is a server and port number 120 is there. Okay. And here there is a rule also telling that allow port number 120 to pass through. When the Nmap devices will start sending all the scans to the devices, what is going to happen? The firewall is going to drop all packets. Okay, it is going to drop all packets. So meaning no response for all 65K ports. So meaning, does it mean all 65 ports or 65,000 ports are open? No. So that is the reason UDP ports scan is never accurate. If there is a TCP scan, same way it gets dropped, I know that something is happening out there. The device is not getting a response. There is a firewall in the middle. I can know about that way, right? That is going to happen out there. But UDP, I will not be able to accurately tell what is happening, the port number. So it is never accurate. We have to assume that is going to be there. Luckily, most of the services which will have critical services don't run on UDP, right? They always run on TCP, and that's going to be useful for our perspective, right? So now let's add one more information, right? Telling to know which port number is open is not sufficient for me. I like to get more information out of it. So what can I do? Can run is Nmap. I'm going to run -p. I'm going to run all 65,000 ports. I'm going to run a TCP scan. And there's one more thing I'm going to do. I'm going to run an SV scan. SV stands for verbose, and this is going to give out a detailed scan for me. So meaning previously it told which port number is open. but it did not tell what software was running on those ports. And thus information can be retrieved using this -sv option on that. And this is going to take some time. And previously you saw when you run the same thing out here, let me do one thing. Let me copy the same scan and run it in a new terminal without SV, right? Without SV, how fast the scan is going to be. Okay, sorry. Yeah, this is going to be almost instantaneous. Everything is scanned, all 65,000 ports are open, were scanned and got the remaining ports that are open out here. But here there is no version information, right? So we'll talk about it. I'll show you the version information here when the scan is complete here. So let it complete, we'll see the difference. Because a lot of things are important for us. For us to be able to attack, I need to get the version info, because then I also need to know the OS version also, right? Sometimes the attack variant is different, right, based on the operating system. There are certain attacks, for instance, very old one, Windows XP, that particular vulnerability is only having affected in a French version of Windows XP, right? Or there could be Windows XP, SP1 series, there SP2 and SP3, right? And that vulnerability I'll be able to completely compromise if the is a SP1 or SP2 series of Windows XP. Or the same thing happens for your other OSs also. Versions also it is there. Okay, so you have to be very careful with that part. So getting information there is very, very crucial for us. One second. This is taking time because it is sending a lot more than that, a lot more than 65,000. That's going to be then out. So probably what I can do is, let me stop this. I will do the top 1,000 ports. If I remove the -P option, it will scan 1,000 ports. So let me do that part and see. So that is why you need to take very careful of the amount of packets that are sent is going to be very, very large. You see Wireshark itself, you can see the packets that are sent. See here, in a very short span of time, so much information is sending out. And it keeps on sending. It keeps on sending out that. Taking a lot of time. In the meantime, anyone is having any questions? Related to network scanning? Me too. Yeah, please.
Ask me. I wanted to ask, the respect of this network scanning.
I didn't get you.
I'm installing Kali Linux now. I will install Kali Linux on my system.
Okay.
And maybe on a virtual machine. And is it possible to also install those server on the same virtual machine and use the Kali Linux as an attacker on the Windows? Or I should install the Windows on a workstation on the same laptop?
Yes, yes. You can have multiple OSs. You can have depending on the RAM that is available out there in your laptop and the CPU capacity, you can have multiple. Say, for instance, for every virtual machine, I'm installing, giving around 2 GB of RAM out here, and I'm running an i7 processor and 32 GB. So I can run about 10 to 12 virtual machines in a small network. I can simulate a small network in my laptop out there and actually do that activity, right? So amount of virtual machines, you can install your own server, you can install your own, let's say running your own Linux server or Windows machine, all those things can be done out there, right? So I'm able to install a Windows VM as well here. That is possible, not an issue. What you're asking.
Without the VM, like can I do the two on VirtualBox and still get the same result?
Yeah, exactly. Yeah, that you can do it on VirtualBox. VirtualBox is also. The main reason I use VMware Workstation is it is bit more user friendly when it comes to managing multiple VMs out there. So VirtualBox works excellent as well. No issues with that. So if you want, whenever you want to download Kali Linux, right? So when you go to that location, you can download the VMware version of it, virtual machine. So if you're having VMware Workstation, download the VMware version. If you're having VirtualBox, you download the VirtualBox. Right? They also support Windows Hyper-V and Chemo also, but most commonly used is VMware and VirtualBox versions of it. All you have to do is download that file, unzip it, and open it. It should work totally fine, not an issue.
Okay, thank you.
Yeah, well. So now you can see that the scan is complete, the version scan. So previously what we got was only the service name and the version was not given. And now here you can get Pro FTPD 1.3.1, OpenSSH version 4.7p1, and Apache version 2.2.8. All this information is given a much more detailed review out here, right? So for instance, let's say is there any you should be able to get some kind of a vulnerability. Yeah, so there is actually a exploit DP command, copy command execution backdoor is there in this Pro FTPD 1.3.3c, and there are multiple things, right? So there is a pre-existing attack process, how to do that, and there's here, there is a Metasploit framework itself, how to attack this particular version, where I can get a completely compromise and get a reversal exploit of that. Okay, so getting this version information is going to be very useful for us, right? And there's one more option, you can give -O, capital O. This will give you OS information. It will tell me what kind of an operating system I'm running, the target is running on. Okay. So this is what your network scan is going to look like. Nessus scanner, where different scans have run previously, and different scan templates that are available out there, right? So you can scan what are the different, there's a separate scan for web application, there's a separate scan for network and specific vulnerabilities. Usually we like to do PCI network scan internal. Here I could specify the targets, all the IP addresses I want to scan, what is the name for the scan is given, and target and everything can be given out there, right? If there is an authenticated plugins, all those things can be taken, right? And again, I can even specify the scan timings also when it is going to be scanned also, right? Usually the scan is going to be almost immediate. So that is going to be there. I can rerun the scans as well. So it is already completed. Can rerun the scan. Now I can't run the scan because some process is running in the necessary scan. That usually occurs. That is the right. So this is what a basically a network scan would look like, right? And it you can run your organization checks and find based on that what port number, what information has been disclosed. Is it running any unwanted ports, or is it showing any information for this particular port like what we are seeing in our Kali Linux, right? So here you could see that I did the service scan. It is telling it is a Linux machine also. So it's still running OS scan. Let it complete. But we are getting this version information. This should not be coming out there, right? This telling Nginx 1.4.0 is also running. All these things, information should not be disclosed. You can see there are certain things, there is no version information. Like for this 5.4 shell or anything, it is nothing. So we should get this kind of information. The banner should not be sent to the response. Okay. So banner should not be sent to the response of that. Right. So this is what happens in a real-time scenario. It is not from a class perspective or anything. When you're scanning a network, and this is how it usually goes. Right. So any questions from network scanners, guys? From the whatever the concept that is explained or in a real-time scenario, how this is going to be there and things. Any questions related to that, please let me know.
Okay, please, I want to ask.
Yeah, please.
Okay, please, thank you for your teaching, sir. I want to ask, when you scan this, during this network scan, all these ports that are open, does it show that the server is vulnerable?
No, it is not mandatory because let's say you're running an HTTP server, web application server, your port number 443 is going to be open for sure, right? So that is always going to be there. So this is one of the security is not a single activity, right? There's no silver bullet for it to do. So there are multiple things have to be done. So we are making sure that only relevant ports are open, unnecessary ports are closed, right? In a typically what used to happen before in older machines is lot of other ports were also open out there, like what we could see there previously when we did the scans. That is not needed. If you're running an HTTP server, only port that needs to be open is port number 443. Rest all the ports should be closed. Then again, you should also focus on port number 22 because the administrator has to connect to the machine via port number 22. If the firewall is configured properly, only port number 443 is going to be exposed to anyone in the public. Rest all the ports is going to be closed because in firewall configuration, we can tell open port number 22 only to the admin pass IP address. Rest everyone will not be able to work on that part. So that is in a conjunction. You have to look into that perspective. Right? So if you have seen our firewall class, you would have understood. That makes more sense. Actually, the class for the main DevSecOps course is about 60 hours. So it's about 6 weeks. But it usually goes more than 6 weeks because yes,
Sir, so TCP was giving us only default ports names. Means it was giving port 443 for HTTPS, but you said that we can change that in configuring firewall. So
Yes,
how can
not the
we
default ports. Default ports changes should be done in the relevant uh, configuration, right? That can be done based on that particular software or the app services you're running. That is going to change out there, right? For instance, let's say if you're running an SSH, by default the port number is going to run on port number 22. Okay, so I can change the default port number. For instance, I'm showing a Ubuntu machine. Let me check. If SSH is running, there is no SSH service. Let me install sudo apt install
Bro.
SSH.
But yeah,
Yeah,
man, let's do the hello.
yeah,
Oh no, sorry, I
yep,
didn't mean to call you.
yeah, no problem. So let's say if you want to change the SSH default port, you can go to vim/etc sshd underscore config. So here you could see that port number is there, specify port number 22. I can change it to any other port number of my choice out here. As long as this port number is used by any of the existing services, I should be able to run very easily out there. So similar way for running, changing the Apache, we can change the port number in Apache configuration file. For FTP also, that's going to be there. By default, this is the number, but I can make modifications for that. Hope
Okay,
that
sir.
was
So
clear, Yuvraj. Yeah.
yes, sir. But sir, Nmap was giving us information about the port. Let's say we changed port 22 to others, some other services. We are using port 22 for uh, we can say TCP handshakes or something like that.
Mhm.
So it will tell us that port 22 is using for SSH services
Yes, yes.
by default.
So, yes, for instance, let's say, for instance, let me, it is research running. Okay. Sudo vim/etc. I'll go here and change the port number to 2222. Okay. 2222. And I'm going to do that. I'm going to restart the SSH service. Okay. So now let me check the IP address for this. I will config 134. Nmap -p 2222.192.168.178.134, I think so, right? Yes, 134. So if I do a normal scan for this particular port number, now it is going to give me something else. It is telling the port is closed. Why is it closed? One sec. It's inactive only. Default it is the SSH running. One second. Right. Okay. No. It needed a restart. The service reload was not sufficient. So then at that time it will tell port number 2222. If I do a normal scan, it is going to tell it is belonging to Ethernet port, Ethernet IP1, right? But when I do the -SV version, it will tell properly that it is running the port number is SSH only, that is going to be there. So that is why it is important to use all different variations of it. Okay. So for instance, now you see it is telling the port is open out there, but it is telling Ethernet. So if I give -SV, after this it will tell that port is belonging to SSH only. See here, now if I give AIFASV, now it is giving the version of it and telling it is running an SSH shot.
Thank you, sir.